Se Ugo ride siamo a posto. Se Ugo è contento siamo a posto. Preparato là. Okay, so it's 10. I would say we can start. Hi everyone, welcome to our talk regarding large language models. So maybe just a really short introduction about us.
So I'm Davide. I'm a machine learning and software engineer at conversational AI at Swisscom. And
I'm Luca. I'm the product owner on conversational AI. I'm the product owner of the platform team. And you can find me on X at that address. A really short introduction on why are we speaking about this topic and why we like this topic or we like to speak about this topic. So we work in the DNA section in Swisscom, so it's data analytics and AI. So what we do is, what we do on our daily basis is we try to automate as much as possible internally. We also try to build market offerings, so we also try to sell our business outside or our solutions, and we empower better decision making through data and analyzing the data that we have in Swisscom all across the company. So we, like I said, we're working in the conversational AI team, and this is our product. So this is what we do on a daily basis, basically. So our product is called Plato. It's called Plato because Plato did a lot of great stuff regarding dialogues, and dialogues is our main main topics or recurring topics. So we automated as much as possible all incoming calls, emails, messages, also letters. So there is still an office that scans letters or fax. They still exist, yeah. And we try, so we have multiple channels and we try to automate them. And as you can imagine, we are doing this topic regarding generative AI because this really changed completely, really step up the game in our world. So generative AI and LLMs. Let me do a really short recap on why there is so much hype in this topic. Of course, I cannot not use a Gartner slide. As you can see, generative AI is really on the top expectation, and there is so much hype that basically everyone is speaking about it and is try to use it whenever possible. Okay, and so what we this last year we really changed completely the game for us, and we are also trying to implement as much as possible with generative AI. I think you all know this interface, right? And this is where the, let's say, revolution or LLM revolution really starts. Okay, but how did we arrive here?
yeah, let's start to have a look to the journey that LLMs and NLP took over the years. So in 1967, everything started with ELIZA. ELIZA was this computer program based on pattern matching that was able to simulate a conversation with a user. Then in 97, so 30 years later, we have LSTMs. It's one of the major discoveries towards the prediction of sequences. And then 20 years later, in 2017, Google invented a transformer architecture that really changed everything. Transformer architecture, which is based on self-attention. I don't know how many of you are familiar with the term. And the idea is that you can do a lot of processing in parallel, where processing means like you can analyze the history of the conversation in a parallelized manner. This works great on GPUs, and since this enabled using GPUs more efficiently, the training architecture could become much larger. You could train models on bigger data sets, and as usual in machine learning, if you have a bigger data set and a bigger model, most often you have great performance. And this, in 2020, brought us to one of the first LLMs, which is GPT-3 from OpenAI, and later in 2023 with GPT-4. And as I said, Google started everything with a transformer paper, And the paper I suggest is reading. It's called "Attention is All You Need," as I said, because of this self-attention module. And there are this Reddit post was really great because it provides a few resources to get started with the topic. But now let's see how the topic bloomed over the years. So in 2019, there was the first transformer LLM from Google, T5. And then in 2023, we got GPT-4. But in between, there are a huge number of LLMs that have been released. And as you can see, like 2022 was a great year for the field. And 2023, even though the slides stops only at March, it really got even better. Like we had Llama 2, we had Gemini from Google, you may have heard of it. We had a lot of open source models like Mistral, Mixtral, new architectures using mixture of experts, new concepts or revised concepts applied to the field. So it was really a great year for this. And we can also see another number from Hugging Face. If you are familiar with the platform, well, it's a kind of like the LLM repository or a machine learning repository for conversational and NLP models, where you can go and download your models and try it on your machine. Everything here is open source, and this means that the community in the world trained roughly 45,000 models for text generation, which means that most of them are LLMs. So this is a really impressive number. And to have a look now at the libraries and frameworks that are actually used in production, we have LangChain. LangChain, you may have heard of it. There was a talk about LangChain 4J slightly before this morning. We use the Python version, but just to explain the LangChain ecosystem, so there is like the core library that offers some interfaces called chains and agents. You may have heard of the terms. And then there is a huge amount of integrations from the community. Again, the library is open source, so you can actually contribute if you have ideas. And this means that there is basically an integration for every vector store, for every LLM, and for a lot of retrieval methods. And this is mainly it for the core. Then there are other ideas like the templates. For example, if you have an architecture in mind, probably already exists. And LangChain tries to help you in building your architecture by offering you some built-in implementations. And like the wrapper that you can see here in light blue is Langsmith. And this is a great tool for model evaluation, for monitoring what's going on in your chains, and also for testing and debugging during prompt engineering. Now Luca will show a bit of code.
Yes, so I think you have seen already some code on the LangChain for J, so for Java this morning, but this is like, so what we did is a bit more with Python, so we have many data scientists in the team, and yeah, they really like Python. So I have a really simple example here, and as you can see, libraries like LangChain really help you to, let's say, speed up your implementation because everything looks super simple. I mean, here you can basically read from top to bottom. It's super simple. So you load some directories, a directory of documents. They can be PDF, they can be Markdown. In this case, it's a Markdown. And as you can see, there is it's something we will discuss about later on because everything looks so simple, but then in the end, there is still some machine learning concept that you need to apply. So like there is a chunk size, there is an overlap. So it's not so easy to set those, let's say, parameters, okay? But the concept is you load a directory of files, okay? Then you try to split them because of course there is, you can imagine OpenAI, it's an API and you cannot provide like megabytes of documents to them. So there is a size, there is a maximum size that you can send to the API, okay? So there is the context window. And so you need to split the documents in some way, anyway. And then you can, so there is this embedding, so we will also explain just in a few slides what they are, if you're not familiar with it. So there is another model to creating the embeddings. Then you store the embeddings. This can be a database, it can be a local database, can be something else more, let's say, structured or more production ready. And that's it. So that's how you, let's say, create the vectors, embeddings for your project. So what you want to then use as a retrieval. And here it's basically just the code that you need to be like a chatbot on top of your documents. So It's really that simple. So again, you have the embeddings models because you need them anyway to also, you need to also create the embeddings for the question. So you need to imagine customers ask something regarding your documents. And then there is a retrieval chain. So chain is basically, you can chain, I mean, they are called chain because you can chain them together. You can have multiple chain retrieving multiple documents or so on. And there is a conversational retrieval chain. And then basically you get the question from the outside, so from the customer, and then the LLM try to build the answer based on the context that retrieves from your documents. Really, that's it. So easy enough. I think, I mean, more than this, I mean, easier than this, it's really, really difficult to have an API, I would say. Of course, again, this is not really production ready, and we will explain why. We also have some findings. That was with LangChain. There are also other alternatives like Llama Index. Llama Index was a bit more, let's say, how to say, it's a bit more optimized, let's say, for this retrieval part. Okay, it's another, basically it's just another library than LangChain, and performs the, let's say, the RAG in a different way. Okay. And regarding LLM, of course, I mean, like we said, the market is so changing on a daily basis that on the slide before we left out, for example, AWS model, so Bedrock, something that comes in the latest months or so on. I think you also maybe have seen something called AWS Q, which is like what I basically present right now, based on the documentation from AWS. And it's basically a chatbot on the website, and you can ask everything about AWS. You can ask, okay, how is it called, the service that's, I don't know, the API gateway service in AWS, for example. And then you have results, but you have, basically you have an explanation. So it's not only giving you back like a normal search. It's not like you got the URL back, you know, and then you need to read the documentation. It's really giving you the answer built by the LLM.
Yeah, and now we want to show you a bit our projects, or at least our ideas. So let's start with something that actually hit production in October. SemBeta is the new version, ideally, of our chatbot, and it was an experimental LLM. An experimental LLM-based chatbot. So it's that's why I said it hit production and it didn't stay. It just we collected enough data to run our analysis, and then we were satisfied with it. So the idea of SemBeta is to have this bot that has natural support for multi-language thanks to LLMs. It's able to perform small talk, so you can say, "Hey, how are you?" and it's gonna say, "Hey, sorry, I'm just a bot, I don't have feelings." And then you can also do question answering about Swisscom related questions. If you go out of domain, it's gonna probably say, "Sorry, I can't answer." And it actually happened. Someone asked to generate a thesis about some historical topics, and luckily it said, "Oh, no, sorry, we cannot do that. It's not Swisscom related." And the RAG part, which I'm gonna explain in a slide, is based on this Swisscom public data in this case. And you can see here like the first message that welcomes you into the chat. Now let's discuss RAG. So RAG stands for Retrieval Augmented Generation, and it's basically the new generation retrieval system, if you are familiar with that. So the user asks a question to your API, to your chatbot, and what happens under the hood is that the embeddings of the questions are computed and are compared with the vectors, with embeddings that are stored in your vector store. The vector store is a database, you can see it. Then only the most similar documents are returned, and then a prompt is fabricated, including this context from your documents, with a question from the user. They are put together, and then you get your answer back. Answer which is generated as say a source of information, so it should be kind of faithful with respect to the information, and also trustworthy because it's your data, so it's not like completely invented out of the blue, and also related to the customer question. So it tries to match the tone of the customer. Just to quickly show you the, let's say, more the architecture, we have an application that is basically the chatbot, the content in that the customer provides, and then there is the embedding model that computes the embeddings, and these embeddings are then put in this vector store. And this is I'd say, how the embedding layer works. And now just to see examples of vector stores, there are some production-ready ones like Redis, PostgreSQL, MongoDB, or even OpenSearch on Elastic. And then there are some more, let's say, local DBs like Chroma that are very good for starting with prototyping in your project. Just to quickly explain embeddings, because we named it quite often, but I don't know if you are all familiar with the concept. So embeddings are basically vectors that represent a word, which have a knowledge, let's say, of the semantic of the word. So it's not just every word matched to a number, but it's basically something that also includes the meaning of what the sentence is. And actually, two words or two sentences that are very similar are very close as an angle between two embeddings. And this is kind of used in a multidimensional space. Here you can see like projected in 2D. For example, like embeddings that are talking about cities will be, here in red, will be quite close together, while something very far, like, I don't know, feeling, will be in a different section of this cloud. And this is kind of the idea, like if the sentence of the customer is quite similar to what you have stored, it's going to basically mean that there are two dots in this space very close. And so you get like, for example, I don't know, you want 3 results, you get the 3 dots that are closer to that sentence. This is kind of the gist. And now we can ask ourselves, but I mean, if this experiment was successful, why to stop only at one RAG chatbot? What if there are different requirements in terms of data? Well, we thought about it, and then we are now working on an answer as a service. We want to enable our internal customers for the moment to have their own RAG chatbot with just a few clicks. They only have to worry about providing the data. And of course, it's a self-service, and it's fully customizable. You can, for example, change the bot name, how friendly you want it. Maybe someone wants a funny chatbot that is grumpy. Why not? It's multi-tenant, meaning that every customer, every tenant has its own separate database, or also its own separate stack. And of course, it's secure and compliant. And now, Luca, explain us, please, why? Because why do we have to wait to only provide this to customers?
Yes. Yeah, exactly. So we also like to try to experiment internally, and all of those examples, they start as internal projects, and then we try to productize the solution. But we like to dog fooding, so our solution. So we like to let's say experiment a lot internally before, and I think we would like to, let's say, give you some ideas. Maybe something maybe it can be something that you also would like to implement in your organization. So we have some ideas or some already implementation already ready for EOD bots. So EOD, so we have some engineers on duty. Basically, they are 24/7, for example. So they are on call, and when something happens, we built like one of these RAG solution with all the postmortems that we had in our system. So we index all our postmortems for all previous incidents and all this kind of stuff. And when something happened, when someone received an alerts, you can already ask in the chat, okay, so was these alerts already happening before? And maybe there was something else that was causing these incidents. And then the chatbot tries to answer this question. And I think this was quite interesting. It's still not perfect, but I think it works quite okay. And then we also have another chatbot with the knowledge base from, let's say, our team, so the internal knowledge base. Maybe you want to have more control over the, let's say, the business logic. And I mean, more control, meaning that the SAM chatbot that we were discussing before, so the one for customers, we are also trying to experiment that with another dialogue manager, so Rasa. I don't know how many of you are familiar with that, but we are trying to use Rasa also with LLM. And also here it's really exploratory work, because also Rasa, we are collaborating with them, so with the company. And so their solution is still release candidate, so they are not yet out in the market, let's say, with the final solution with Rasa, with LLM, so it's really exploratory. So all those examples are really something that, yeah, works, but maybe not so production ready.
Sorry, I haven't understood which kind of software this Rasa is. Is another...
It's a dialogue manager. So dialogue manager, it means, so if you want to build a chatbot before LLMs, it was not so easy to, or not so straightforward to put everything together in place. So you you have like stuff like session replication, because you want to keep the session. I mean, you want to build your bot in a, let's say, microservice architecture maybe, and multiple components. So the dialogue manager is actually helping you keeping the state of the conversation and helping you in some other ways. They are trying to also introduce LLM into their products, and yeah, this is still also for them is still still not there yet. So they are also trying to try to do that, and this will be basically this will be the next iteration on our chatbot, and again, also, okay, so the cloud provider, so. Like the slide before, there are many models right now. So there are many players in the market. So also AWS lately with Bedrock entered the games of LLM. So we are using mainly OpenAI. So we started mainly with OpenAI, but then we also wanted to, of course, try to have something that we can manage a bit more. So maybe try to deploy our LLM. There is also like an initiative to have like a Swiss LLM, so something like this. So I think the ETH and APFL and so on, they are also trying to build something custom, which would be really cool, would be really interesting. But we would like to have something a bit more maybe that we can control, or we are in control. Maybe we can also fine tune, and we are also trying to deploy like Llama or Llama 2 or Mistral and so on locally. And there are some open source models. So as you can see, as you remember before the slides from Hugging Faces, there are so many models right now, open source, that you can deploy and run. And we are also conducting some experiments there. The issue is some are still not so good at, let's say, multi-language, handling in multi-language. So they are really good in English. Usually Italian is like the last language that they are good at. Yeah, that's an issue, but yeah. If you want to support all 4 Swiss languages, basically 4, because we count also English, it's really difficult, and probably OpenAI is still one of the best right now. But in the future, for sure, we would like to have like a custom model. Probably we would like also to, there are also methods to fine tune the models. So there is LoRa and so on. Yeah, it's maybe a bit outside the domain. We can maybe speak a bit later on if there are some questions, but it's a bit too technical, outside the topic, let's say, of this presentation. So yeah, there is also some ways to fine tune the language model. And so here we just copy paste something that happened last week. So just to tell you how, let's say, the game is getting, let's say, is getting real. So Swisscom actually signed a contract with NVIDIA to provide even more AI solutions. So LLM is really, let's say, we are in the hype phase, but we are really trying to push it everywhere or whenever we can. So at the WEF, so in Davos, there is the AI house, and we were also there at the AI house, and there were many companies discussing how to introduce generative AI. So this is really like, I really would say, was the hype for last year, and this year will be the year of implementations, I would say, something like that. So we will see even more AI products in the market. So coming back to the dog fooding part, so we were thinking about how we can also try to improve the life of our developers with LLM, because until now we just thought about some documentation, maybe fetching some question for customers and so on, but let's try to see if we can do something regarding developer experience maybe. And regarding developer experience, we did some experiments there. Some were really fun to work with. They were really interesting. Like we said, the internal bot was the one where we try to use the postmortem and all the documentation that we have internally and try to reply. We have a pull request agents. So if you have seen the keynote this morning about code review, that's perfect. So we try to automate the first review with LLM to shorten a bit the feedback loop. So we try to have, as soon as you open your pull request, we parse the source code and everything. We check them with an LLM, and we try to get some feedback as soon as possible. I will show you some screenshot later on. Yes, that's interesting. Yeah, keep in mind this is experimenting. Okay. Sorry? Not really. So we are internally we are not using GitHub. So we are using another Git repository because of Git source. So we are using GitLab and so on. So it's not a GitHub action. It's anyway a webhook. Yes. So when you open a pull request, there's a webhook to a service, and then there is a reply. Yes. And then, yeah, some chat ops. We briefly discussed about that. This would be even more dangerous. So the pull request agent, it's something that we are trying out. So as you can see, when you open a pull request, there is an analysis. Okay, so the LLM understood that the main theme was fixing some refresh token expired, for example. There is a summary, so you can also ask the LLM to change the summary of the pull request. Okay, so because developers sometimes are a bit lazy. I'm also in this category. I mean, the summary is actually the title of the pull request. So the LLM is actually also able to understand the context, change the title. There is a type of pull request, so it's like an enhancement or a bug fix or so on. What's really interesting is the estimated effort to review. So we also try to estimate how much time is needed for a developer to review the pull requests. And as you can see, there is 3 from 1 to 5. So like this, the developer should understand how big is the PR or so on. And if there are some security concerns. Here it's something we still would like to work a bit on this. It's right now it's just really simple stuff. This is also an example. Also, we also have this inline comments. And I mean, this is completely generated by LLM. I mean, no human in the loop here. So as you can see here, there is some Go code, and at the end there is a return nil. And the LLM figured out that, okay, at the end of this function, it's better instead of returning nil, it's better that you have also returning the error instead, you know, or something like that. So this is, I would say, interesting. So keep in mind there is still an experiment, okay? So we don't want to replace the feedback from developers. So like the the keynote from this morning was really interesting, and but still I would say helps, let's say, to short a bit the feedback loop. So the developers, they open a PR, and as soon as basically in a few minutes or even less, they have some feedbacks there. And for simple stuff, we find out it works quite nicely, I would say. Okay. For the internal chatbot, this is the example. So we use Teams, so we build something integrated in Teams. So as you can see, you can just basically tag the chatbot, and you can ask whatever you want. Okay. So our project, as I said before, our project is called Plato, and you can ask basically, how do I access our Jaeger instance, for example? And then it provides you the URL, provides you some information. Also how to filter for data, for production, for development, and so on. And this is, so the findings of this is that it's great for onboarding, basically. For onboarding new developers, this is great. Because all the simple questions like this one, they basically, you don't need like someone else answer that, okay? If you have more complex question, sure, we don't want to remove the, again, to remove the pairing or code programming or code or discussion between developers. But for this really simple stuff, it's great. And we also find out that it's great for runbooks. So if there is an issue in production or there is something that you want to act, and you can also ask, okay, I received this incident or this alert. What should I do? Or I need to do this action that is actually described in the runbook. How should I do this action described there? And then by just using our knowledge base, indexing our knowledge base, as you can see, the LLM is able to rephrase the answer and just give you the answer directly in line there in the chat. We also find that it's interesting because, at least for us, so what happened when there is an incident, we have a war room channel, we start like a discussion there, so we start like a topic. We say, okay, there is this incident in production for everyone, all the engineers to know what is going on. And then this usually leads to a huge discussion below, like many comments, okay? And it's super easy, you know, to lose the focus there, because maybe you are replying, yes, I already checked that, then you switch to a browser, you are checking stuff and so on, you come back to the chat, and there are like hundreds messages, okay? And you need to go back and check all of them and so on. Instead, like this, I mean, the bot replied directly with your knowledge base inside the conversation. So you don't need to switch, go to a browser, check the web page and so on and come back. So we think this is something where probably, I mean, one of the best implementation we had, okay? And this is just RAG, so basically what we presented before. So we just use our knowledge base, we index the knowledge base, and then the LLM is able to get the knowledge that he needs and then rephrase the answer.
Yeah, and now let's start with some learnings that we got through our journey with LLMs. But first of all, let me ask you, how many of you have some knowledge with prompt engineering or have tried ChatGPT? Okay. Tried, but yeah. Yeah, okay, it's fine. Okay. So if you tried prompt engineering, you may know that prompt engineering is not really engineering, but is rather trial and error. And to me, this is true unless you have a systematic way of testing and evaluating your changes. So we started doing that. We have a contact with some startups, most of them in the US. LangChain is actually Langsmith, so the wrapper that I showed at the beginning, when discussing the library. And these providers provide some frameworks to keep track of your changes, of your prompts. You can define there your dataset, and you can run some evaluation on this dataset. Regarding the metrics, you can define, there are some existing metrics that they provide directly, but you can also design your own custom metrics. I will really recommend to look into this tool because it really changes your life. Otherwise, every time you change a tiny bit in the prompt, you may break some other functionality. Like prompts are becoming kind of the new code in a sense. And in code, we have tests, right? So everything, if you change some code and the test fail, you know where to look. In prompts, there is no such behavior. There is no such thing. So having tests in the sense of data in a data set that you can actually run and see if something fails, I think it's really important to avoid bug in production. And another thing related to prompt, this is about security, is to always assume that all the information in your prompt are gonna be leaked to the user. So never put, say, sensitive information there, because either for a mistake of an LLM or either because the user does some prompt injection, it's gonna be leaked. So this is kind of the safest way to deal with that. Now, speaking about cloud providers, I mean, we are using them, and I think they are a great way to get started, at least for prototypes, because just with a prompt, you can get a lot of tasks done. For example, machine translation, zero-shot classification, PII detection, you name it, it can be done probably with LLMs if it's related to language. And this is great, actually. I mean, you should start testing your ideas with this approach. Cloud providers are really an API interface that you can call and get your result back. So it's amazing. However, when it comes to production, you may want to have something with a lower latency, and of course, with you want to keep track and keep a control over your costs. And here I wrote, BERT is still there for you, and BERT is a pre-trained transformer model. It's kind of what was used before LLMs became so famous. And they are still there. You can still do classification instead of with LLMs by training your own transformer. This is what was used before, and this still probably is still better than what LLMs can do, depending on the task, of course. And if you still need LLMs, try maybe to assess, to evaluate if smaller models can actually do the trick for you. Maybe, for example, for a chit chat, for a small talk, you don't need GPT-4 with, I don't know, like 1 franc per call. Like, you don't need that expensive solutions. You just need something that can run locally, maybe. I mean, you just have to say to the customer, how are you? I'm good. You? So this can be done by any LLM, basically. So try to assess that. This is great advice for your budget. And fine-tuning, you may need it, but it's really the last resort. There are many techniques that come before thinking about doing fine-tuning. Like, for example, you can put examples in your prompt. You can run some more complex prompt engineering, like chain of thoughts. You can do this technique called prompt tuning, or you can do RAG. If the problem is that the LLM is not up to date with the knowledge, you can provide the knowledge, as we discussed before. And speaking of RAG, there are really many techniques to improve your pipeline. Now, the architecture that we showed before is just really the beginner level RAG, and it's totally fine for some simple application. But for more complicated, let's say, retrieval, and if you wanted to improve your performances, for example, you can have a look at custom embeddings. You can train your own embeddings model, and this should work probably way better. You can do, for example, multi-query retrieval. This is an idea. I believe it's also used in search browsers. So, for example, I think Google does that on Google Search. So when you run a query, you generate variations of this query, and then you run in the database some searches in parallel, and then you put the results together. And this probably will lead to better results overall. And one way of putting these results back together is this reciprocal rank fusion that I wrote there. And it's the idea of performing a ranking of the results. Then there is also similarity ranking, something else that you can try. And in general, if you have a conversation, the user may suddenly ask a question that is related to, I don't know, 3 messages before, right? And so this query rephrasal, it's quite important to keep track of what's going on in the chat history. And the most difficult part of RAG is actually what Luca was saying before, getting the right document chunk size. So the document can be, I don't know, thousands of pages even, and this for sure doesn't fit in a LLM. So what you need is to split the documents into smaller chunks. But what's the correct size is actually super difficult to tell. Why is that important? Because if the chunk is too big, maybe the embedding quality is worse, because there are too many information there to actually be portrayed really well. However, if the chunk is too small, the information can be fragmented, right? So maybe the user is asking something, but actually the document is split. There is not the right number there, and then you don't know the price of the product. You just know the name, maybe something like that, because it was exactly split in the middle. So this is kind of something to take into account, and unfortunately there is no real answer for you. There is no a real ideal number. It depends on your data, and that's why also evaluation is important. If your RAG pipeline or if your chatbot doesn't perform well, maybe you run an evaluation on a data set, and then you say, okay, maybe we can try to tweak it a little bit, and then you get better results.
Sorry, one question about this segmentation. When you split your document
Yep.
in segment, every segment is an entity on its own, or there is some relationship and the LLM knows that this segment comes immediately after this other?
Great question. So ideally, first of all, you do chunking by splitting exactly at a limit, but you kind of overlap the 2 chunks.
Okay.
And then there is some advanced retrieval technique that is called hierarchical RAG. And then you actually, it's what you said. So basically, there is a parent document, which is the entire document. And then you can retrieve first the parent document. For example, you can also use a summary of the document. And then the LLM says, this document can continue the answer. Let's try to have a look further in this document. And then you retrieve the chunks. So there are, as I said, like the I think the limit is the imagination with LLMs. Really, you can do a lot of
Yeah,
stuff.
I think in this case or in this example, so we did some experimentation. So with our knowledge base, there is also a way to super simple way to split by just titles. Okay, so if the document is a markdown, you just split by the titles in markdown. Okay, so you check for the hashtags. And what happened? I mean, if you don't, if you don't do this by title, but you just specify like a chunk size randomly and so on, what happened in our, I think happened with the Sam with our chatbot beta. So the list of countries, so Swisscom, so when you want to call to another country, basically, so there is a list. So cost is different, okay? So from country to country. The list was longer than our, let's say, chunk size. So the answer was actually not right to the customer because we cut out some countries, you know? So that's an example, you know, a concrete example on how important it is, this chunking or this to cut the documents at the right size. Yes.
Yep. And like, we want to conclude by saying that working with LLMs is super fun, and you should try if you haven't done it yet. There are really nice ideas out there and nice, a great potential for innovation and for our future. I believe like it's gonna probably bump your productivity, or even you can feel that you're doing something really cool. And I mean, I love it. We love it, I guess, and you probably are gonna love it.
We're also having fun.
Yes. And yeah, this is all. Thanks for listening. I guess we have a few minutes for questions.
Yes.
Yeah.
Thank you. It was super interesting. I was wondering if for RAG you already considered having the LLM split your document in an intelligent way, and also for this checking how big the segment should be and overlap, if you can actually let an LLM evaluate the results of different parameters.
So I had a few ideas. The main issue is the cost, because if you have, I don't know, like 10,000 documents, this would mean like a lot of bucks in terms of cost to OpenAI. So for sure, this is a good idea. Also because you can, for example, summarize maybe the content and use an additional embedding in your research, in your search when you do the vector search. So there are like even the preprocessing can offer a lot of opportunities, and I think this is valuable because you can actually say use an LLM to find the best way to split the text. But as I said, like as a matter of fact, we should also take cost into account, especially when the document goes in the 4 or 5 digits number. So, but this is also a nice, very nice approach. But yeah, and also it's not a solved problem. I believe like this year, I don't know, maybe 20 more papers are gonna come out with a new idea. Like, I don't know, my LinkedIn feed is flooded with papers every 2 days. Yeah, they found a new LLM, a new vector store. It's great.
How you deal with hallucination? I mean, did you find this solution to hallucinate, and it is better when you do RAG? I mean, when you do RAG, probably it's more contextual,
exactly,
so you have less hallucination. How does it work in this case?
Yes, exactly. As you said, RAG really helps with hallucination, still doesn't solve it. Actually, nothing solves it so far. What helps, and we are going the direction, is actually to estimate it. So I have some sort of evaluation tools, as I said, like a data set, where you can actually measure how much your solution hallucinate. But keep in mind, like, hallucination is just a fancy term for a misclassification. Like we had it before with classifiers, right? Classifiers are not perfect. They can make mistakes. The thing is you can detect them. Hallucination is like the way that LLMs make mistakes.
It's not solved yet, basically.
Yep.
But with RAG, you try to use only the context, you know, so the context should be really specific, so the LLM in the end only rephrase a bit the context. So you try to really reduce the hallucination.
Yeah, but it's not really only classification. I mean, it's really
I know, yeah.
inventing stuff. I mean,
Yeah.
my very first experience with ChatGPT, I asked it, I like this kind of music. Please suggest me some other albums that I can listen. And he suggested me groups that I know very well with the name of an album that I didn't exist. That I didn't know. I was surprised. I was looking for it, and I found that it didn't exist at all. But he was totally
Yeah.
inventing it.
Like a more practical example is for links. Like we had the issue that it was hallucinating links. Like the customer was asking something, and then you can go here. You get there. It's what is that? And so in this case, links are quite easy. We kind of parsed the links before returning them to the customer. And if they didn't exist, we were asking the LLM to rephrase the answer without links. This was, for example, a post-processing step that we did to make sure that this was kind of enforced. But for, let's say, for sentences that are completely wrong, this is no solution at the moment. So you have to deal with that.
Thanks.
Do you have time for one last question?
I think we're out of time.
Yeah.
Let's try. I don't know.
Have you tried, didn't see in your presentation, but have you tried before some web retrieval instead of documents and stuff?
Yeah, so...
I tried it, it was less funny than working with pure LLMs. Things you get from the web sometimes.
Yeah, you
and
know...
it's difficult to verify if it has a similarity with the question of the user for sure, but maybe you tell me about Coop, the supermarket in Switzerland, and it finds the Coop in France. I mean, it's difficult then to control this aspect of the reg.
So you mean really with like using a tool to look on the web, for example?
To look on the web,
yeah.
embed the stuff that gets on the web.
Yeah, and also another challenge with that, if I may, it's also that the format of the HTML cannot be so simple to kind of parse the LLM. So this is another issue. You need to convert it to Markdown, but then also most of the time websites have JavaScript scripts that run and get the content. Also, actually, this was an issue internally to the Swisscom website, where some widgets use JavaScript to get the content, and then you don't have any information. You just have the title of the web page.
But it's evolving, it's getting better. Let's see the 100 products will come this year. Thank you.
Mm-hmm.
Very fast. Works fine. LLM with documents. Works with logs. How it works? Logs of programs. Log files.
Log files.
Yes.
Yeah. Well, we haven't tried yet with logs. That could be an interesting way to try out. Yeah, I think logs, I mean, depends on the information in the logs. Probably you want to mix logs and some kind of knowledge base or something like that, you know,
some
together.
Context,
so you mix, I mean, you give some context, you give the input, the log file, and then try to fetch some information from your knowledge base, I would say. Yeah, something like that. Okay. Thanks.